All right, so we're going to do 5.4 complex numbers day 2. This time we're going to focus on multiplying and dividing rather than adding and simplifying. And we also did some subtracting yesterday. So multiplying complex numbers, basically if you look at number 1, think about it as an x, right? You would FOIL here, right? Or in other words, double distribute. So you're going to do the same thing here, okay? But there's i's now. So we're going to take the 2 and distribute. So 2 times 3 is 6, 2 times 7 is 14, and then we have an I. Then distribute the negative 5, and we have negative 15i, and then a negative 35i squared. At this point, we're going to simplify, right? Obviously, we can combine the i's, so we're left with 6 minus I, right? And then we have I squared. If you remember from yesterday, I squared is negative 1, right? So in reality, this is negative 35 times negative 1, which would mean that it's plus 35, okay? In the future, all I'm going to do is cross out the I squared and then change the sign in the front, right? Because that's what happens when you multiply by a negative 1. So now we just have to clean it up. 35 plus 6 is 41. We have 41 minus I. On the next one, similar question, we're going to distribute the 10. So 10 times 10, 100. 10 times negative 4i is negative 40i. Then we multiply and distribute the 4i. So we would get a positive 40i. And then 4i times negative 4i gives me a negative 16, and then I squared. So if you notice, the middle two cancel. You're left with 100 and then minus 16i squared. So remember, the I squared becomes a negative 1. So we really just have to change the sign. Final answer would be 116. Okay, there's no i's, so you don't have to write it. You could put plus 0i just like you could put plus 0x, but it's not necessary. All right, so the next one, radicals. If you remember radicals and whenever we had fractions with square roots, you can't have them in the denominator. Same thing is happening here. When you have an imaginary number, you cannot have an I in the denominator. So we're going to have to get it out. Okay? And the way to get it out is to multiply by it in the numerator and the denominator. So what I mean by that is if you look at number 3, we're going to multiply by I over I. Okay, the reason why we could do this is because I over I is actually 1. So you're multiplying by 1, you're just making it look. Okay, so when we multiply fractions, we multiply straight across. So we have 3i over I squared, right? Remember from what we were just doing, we know what I squared is. I squared is actually negative 1. So you can have it as something like this, or the best answer would be negative 3i. If you look at number 4, now we have 3i in the denominator. Even though the 3 is there, we don't have to get rid of that. You can multiply top and bottom by that, but then you're going to have to simplify later. So I'd rather just stay with I over I, because we can have a 3 in the denominator, but we can't have an I. So now we have negative 8i over 3 times I squared, right? And remember, I squared is really just negative 1. So now we have negative 8i over negative 3. The negatives would cancel, and you're left with 8i over 3. For 5, very similar question. Again, we have 4i in the denominator, so we're going to multiply by I over I. This time, though, I don't know why I crossed it off. This time, though, we have a binomial in the numerator, so we are going to have to distribute that I to both. So 3 times I is 3i. 2i times I is 2i squared. And our denominator is 4i squared. So now we need to change both our I squareds to negatives. They are negative 1s. We're left with 3i minus 2 over negative 4. Okay, now you can leave it like this. You can get rid of the negative in the denominator. Often they do that. So if you do that, you would have negative 3i plus 2 over 4. Okay, probably the most correct would put it as 2 minus 3i over 4. Okay, but I'm okay with all these. Now, some of you might be thinking, wait a second, 2 over 4, I can reduce that. So can't I just have the answer of negative 3i over 2, right? No. Okay. Big thing with reducing these fractions. In order to reduce them, all 3 numbers have to be divisible by something. So because that 3 is there, I can't simplify the 2 and 4 because the 3 is not able to reduce by 2 as well. All right, and then number 6. Again, we're going to multiply by I over I to get I out of the denominator. And because we have a binomial, we're going to distribute it. So we have I minus 8i squared over squared. And I squared is a negative 1. That means that they change the signs. So we're left with I plus 8 over negative 1. Or we should reorder it, so negative I minus 8. Or sorry, let me try that again. Negative 8 minus I if we get rid of the negative 1 in the denominator. Again, I'm not overly picky on how you simplify that last part. This is an acceptable answer to me, but this is the most correct, and that's how I would write it. Now let's talk about the conjugate. Okay, we're multiplying the numerator and denominator by the denominator with the middle sign changed. Okay, so what I'm saying with this, if you look at number 7, we can't multiply by just I anymore because there's a plus in there. So whenever there's an actual complex number in the denominator instead of a pure imaginary with just I, you have to multiply by the conjugate, which would be 3 minus 6i this time. Okay, so notice how it's the exact same as the denominator, but the middle sign is changed. So now what we're going to do is we're going to distribute the 2i. So we would get I minus 12i squared. In our denominator, we would FOIL. So if we distribute the 3 first, you would have 9 minus 18i. Then if you distribute the 6i, you would get a positive 18i minus 36i squared. At this point, we need to clean some things up, right? If you notice, in the numerator, I squared becomes negative 1, so that's really a positive 12. I'm going to rewrite that as 12 plus 6i. In our denominator, 18 i's cancel, which will always happen with the conjugate. Okay, the middle 2 are going to cancel. And then we have I squared, which makes the 36 a positive. So we're left with 9 plus 30. If we keep cleaning it up, we have 12 plus I over 9 plus 36 ends up giving me 35. Okay, now this is a pretty good answer. Okay, the problem is that every single one of them can be divided by 3. So because all 3 terms can be divided by 3, we need to simplify. So the most correct answer would be 4 plus 2i over 15, because all 3 of them can be divided by 3. Now looking at number 8, multiply by the conjugate, so 1 plus I. We're going to have to FOIL on both of those. So in the numerator, we distribute the 2, we would get 2 plus 2i. If we distribute the I, we get I plus I squared. In our denominator, distribute the 1, and we get 1 plus I. Distribute the negative I, we get negative I minus I squared. And now we clean it up. The numerator, we have 2. If we combine the i's, we would get 3i. And then remember, I squared is negative 1, so we have minus 1. In our denominator, the middle 2 cancel, which should always happen. And now we have 1 minus I squared. Well, if I squared is negative 1, 1 minus negative 1 is actually 2. So our numerator becomes 2 minus 1, which is 1, plus 3i over 2. At this point, go ahead and try number 9 and 10. They do mirror numbers 7 and 8. So pause the video and go ahead and get started on that one. And then I'm going to go through it pretty fast. At this point, you should have had enough time to go through these if you pause the video. So I'm going to get going on these. So number 9, the conjugate would be 3 minus 5. So if we distribute the negative 2i, we get negative 6i plus 10i squared. In the denominator, we would end up getting, if we distribute and FOIL, we would get 9 and then minus 15i plus I, then minus 25i squared. So if we get rid of the I squareds, this becomes a negative 10. And in the denominator, the I squared would become a positive 25, and the middle two cancel. So if we rewrite this, we get negative 10 minus 6i over 9 plus 25, which is 34. That's an acceptable answer, but the most correct would end up being negative 5 minus 3i over 17 because all three terms can be divided by 2. On the next one, when you multiply by the conjugate, 2 plus 4i, we now have to FOIL in the numerator and denominator. In the numerator, we would get 2 plus 4i when we distribute the 1, then 2i plus 4i squared when we distribute the I. In the denominator, we would get 4 plus 8i, and then negative 8i minus 16i squared. Then we're going to get rid of the I squared, so this would become a negative 4, and the denominator would become a positive 16. And then our i's cancel in the denominator. So our denominator is 4 plus 16, which is 20. Our numerator, if we combine 2 minus 4, we get negative 2. And then 4 plus 2i ends up giving me 6i. Again, that's a good answer. If we got that far, that's great. But we can simplify it because all three, again, are divisible by 2. So we would get negative 1 plus 3i over